Hi, this is Don from Lakewood. I'm going to give you a bit of an overview of some testing we did on one of our new precipitation gauges. It's a passive type, non-heated, and it has a small, very accurate pressure transducer in the bottom, and we preloaded with some antifreeze to give the fluid level as the snow melts in the unit. If we take a look at the information that we have here, there's a photo in the upper section here that shows our precipitation gauge, and then to the left of it we can see the reference gauge, which is a heated 8-inch tipping bucket Texas Electronics gauge. This Texas Electronics gauge is set up with the factory approved option for melting the snow into the gauge and monitoring the precipitation. As we can see coming in here, there's a yellow electrical cord coming into a AC electrical boot protector, and then the terminal box is over here on the left. The blue cable loops around, comes in on that left side. Over on the far left side here we can see the data logger hooked up to the side of the rain gauge. Below this rain gauge we've got an antifreeze collector which picks up the snow melt as it comes through the top of the collector, and we use that antifreeze collector here as a verification of the totalized melted fluid that went through from the snow into the section here. So what we try to match up what the data logger has as a totalized number off of the tipping bucket to what we actually see on the small sight gauge on the side here. Now I'm going to compare the test information that came off of the precipitation gauge relative to the heated tipping bucket gauge that we just discussed. As we see here, the data off of the heated tipping bucket gauge starts out and goes through sort of a stair-step type of output here, and that's shown by the darker red lines. The corresponding data that was recorded by the non-heated passive precip gauge, the PG6, is shown in the bright red graph that we see going along here, and we can see the analog data that's coming off of the submersible pressure transducer that's used inside the gauge itself. Now, the graph down below, there's a corresponding temperature graph down below in which we can see the interaction of some fairly severe temperature swings on the gauge. So that's showing us the effects up here of the temperature swings as it affects the small submersible pressure transducer in the unit. And we can see it's holding quite well with temperature because we've got quite a temperature swing here, looking at down into minus 25 degrees or so, up into 4 or 5 degrees up in this section here. And yet the gauge does seem to track fairly closely. The precipitation gauge was initially synced to the data at the starting point over here around January 13th. And then the analog data was scaled to the digital data at this point here. There's several snowstorms that occurred during the recording of this data, and various wind conditions had also occurred while this data was being recorded. Now we'll take a look at some of the details of the precipitation gauge itself. Starting from the bottom in the photo here, we notice that the gauge is coupled to the base of the instrument here with a rubber coupler This has clamps on it that can be removed so that the precipitation gauge can come off, and if need be, gauges can be swapped out in the field, or we can put a regular tipping bucket in its place during summer operations, and that rubber coupler on the top here is compatible with both the 6-inch Texas Electronics gauge and this precipitation gauge. The base of the unit is comprised of a 6-inch pipe, and this pipe has special metallic coatings on it to prevent any buildup from static as the snow blows by it in the wintertime. This base also contains one of our data pack data loggers in it, and that data logger inside is connected to the outside of the case by a small connector. In this case, we have a Bluetooth communicator that's plugged into that connector, and that Bluetooth communicator has the capability of communicating up to about 100 meters or so. It's rated as a Class 1 Bluetooth device. Now, on the left side here, we notice there's also a drain valve on the unit, and this drain valve is handy for draining the fluid out of the gauge at the end of the recording season and recharging the gauge, or just in doing minor adjustments. The gauge has a 30 centimeter range, so that's quite a bit for the operation of the gauge during the winter period. The sight tube on the side of the gauge here has a small black copper pipe placed inside it, and that copper pipe is used for solar heating to make sure that the fluid in the sight gauge is always kept in a liquid form, although most of the time this antifreeze that comes in that's fed in from the bottom of the gauge up is usually quite concentrated, and we haven't seen any issues with that antifreeze freezing in the sight tube at this stage with very low temperatures. Continuing on the left side of the gauge here, we see that there's another line that's connected up to the top here, and that's a back vent line for the internal submersible pressure transducer, which allows us to cancel the effects of wind as it blows over the top of the gauge. As the wind blows over the top, it'll create a vacuum, and if this line was down below in the bottom here, there would be a pressure differential, and since this pressure transducer is very sensitive, this would normally show up as noise on your data, and we can see from our test data that there's no interaction of wind noise on this particular gauge. So that's an overview of the PG6 precipitation gauge, the non-heated passive type. Now we can take a closer look at the inner workings of this precipitation gauge. The gland area that couples to the base of the unit is shown here, where it's opened up, and the bottom part of the gland is showing the mounting of the pressure transducer and the venting lines in that. Now, if we take a look at this is the vent line that we talked about earlier that back vents in from the upper part of the gauge to reduce the wind effects of wind on the pressure transducer. This back vent line comes through, couples into a desiccant chamber that we have here, and this desiccant chamber is connected to another block that separates out the straight instrument cable with the instrument signal on it to the data logger here, and then the main vented cable comes into this side of that connector block. The cable loops around on the inside, then goes through a pressure gland here, and this then is set up so that the pressure transducer sits upright into the bottom of the precipitation gauge and picks up any change in fluid level as the snow drops into the antifreeze preload and the level changes as it melts. We can see also on the left side the valve assembly and part of the sight tube coming off here above the valve assembly. Thank you for reviewing this information with me. If you'd like to contact me, I can be reached at Lakewood at 462-9110, or my email address is don@lakewood.com. Thank you.